Or how many of you guys are thinking about using HTML5 but worried about, hey, my apps needs to work offline, it has to use GPU acceleration and such and such. Okay, cool. So we're going to cover that in the next 30 minutes. So how many of you knows this logo? Nobody? Okay. Can anyone tell me what's the relation with this and HTML5? This is the Autobot from Transformer. I mean, Transformer, you have Autobots and Decepticon. Pay attention carefully. So for me, HTML5 is one of the Autobots, so really good guys. So my name is Ariya. I work for a startup called Sencha. And in the next couple of minutes, or like 30 minutes, we're going to see how HTML5 is going to be used in developing apps. Originally, the topic was about Windows Amigo, but hey, last night I had to change it, so it's about Python. Before starting, let me show that I worked on different open source projects before. Qt, it was part of Trolltech. It was product of Trolltech that acquired by Nokia. And then I also contributed to WebKit, and before I was a long time KDE developers. So along this line, I moved towards more to the website or to the web platform. HTML5. So I'm going to show you 2 points. You're going to see first how to use HTML5 in pure web apps, meaning that one straight off the browser, no need to install anything. And second, I'm going to show you why you need to take into account web technologies if you even want to deliver an application, say, right in the App Store or AppUp. So two big categories, and at the end of the presentation, if there's time, there's a bonus slides about how GPU acceleration works on hybrid apps. So first, pure web apps. So there are this common myth about web apps, or like something that cannot be delivered using web technologies, like it's slow, doesn't use GPU acceleration, you have to write your JavaScript code manually, and all these crazy things. But there's a misconception. There's a gap between native developers and web developers. So, for example, if I go to my friends who only use JavaScript and web technologies to build apps, and I say, hey, I used to create apps that I can compile for Linux, Windows, and Mac, and they will like go crazy because how do you do that? Are you learning Objective-C and MVC and X11 at the same time? No, you just need to use Qt, right? So there's a misunderstanding there. The other way around, if I say to my Qt friends that, hey, I create this app at once on the web, oh, do you need to write JavaScript manually like in Notepad, and then next to your editor you have browser and you click refresh all the time, you manually lay out everything, what if there's a missing enclosing tag, etc., etc. So if you write your web apps this day, you don't really need to write it like with raw editor. You can use tons of frameworks and libraries that helps you speeding up the application development. Same with, hey, I can only use JavaScript, or the application will not run on different platforms, different devices. I cannot do crazy animation because I need to work with this funky DOM and such and such. We're going to show that this is not all true. If you ever develop an app and then deploy it on different devices, you know how difficult it is in such a short period of time to deploy it across different devices. If you ever develop apps for iOS and suddenly you need to take into account Android, then you need to forget your Objective-C in your brain and then start learning about Java, and who knows what platform will be popular in the next couple of years. So by taking advantage of HTML5, you can create the apps that works across multiple different platforms. So as you can see, I still haven't included Tizen logo in this slide. Or remove Migo and put Tizen. So adoption is also a problem because it goes against the mainstream, and it's difficult to show, hey, you have to use HTML5 because there's no really like very popular HTML5 apps. But this day we do have that. So if you use Amazon on certain tablets, it works. How many of you here already use Cloud Reader? It's a pure web app. You go to the website, install a shortcut. It works beautifully. It feels like a normal native app. So I use this to read my books. Or Financial Times. Recently, there's a report that the web version of Financial Times actually used by more people than the native apps. And if you see the display here, it looks really like a normal magazine. Although behind the scenes, all use the web technology. And it works offline as well. So when you want to use JavaScript, then there's a lot of challenge. How do I move from C++ to JavaScript? Fortunately, there's a lot of resources out there to help you understanding this. I don't know if one of these books is in your HTML5 kit. Probably not. Although I think this is one of the most important parts. Should have been in that kit. How many of you here already know JavaScript? How many of you here think that JavaScript is bad? Okay, so. You see that the JavaScript these days is not like what your mother used 10 years ago. So if you think JavaScript is there to make some image rollover when you put the mouse there, that's not necessarily the case anymore these days. People build crazy apps just using JavaScript. So if you see the speed here, that's like Internet Explorer 8 a couple of years ago, and if you use modern browsers, it's like a fraction of time. I should have even put the logarithmic scale in this graph to make it more fair. And again, like I mentioned before, if you write in JavaScript, you don't necessarily write everything by hand. You can use EXJS, Product Sencha, jQuery, very popular, there's Sprout, Dojo. Any of you use any of these toolkits? Which one do you use? jQuery a lot. Anyone using EXJS? So a lot of this framework, this library helps normalizing the cross-browser differences as well as speeding up the development because you don't need to write your own widgets.
Which are these libraries? Which are frameworks?
The EXJS is framework.
Oh, I see. Okay.
You can Google later on and then check about this stuff. What about offline support? So I'm going to put some slides here because this is a common myth. Every once in a while somebody comes to me, I want to use web technology, but my apps need to work offline. That's not a problem because they are not mutually exclusive. So there are two features of HTML5 that you can use to make your application works offline. First is application cache, and then second is local storage. So app cache needs some support from the server side in the form of the cache manifest file. It's usually called application name.appcache. And the way it works is that this is defines what resource needs to be accessed when the user is offline or when the user is online. So there are three categories. The default is cache, meaning that if the user doesn't have internet connection, then the browser should use the resource that is put in the cache. Or the user needs to use the resource in the network. Because, for example, a login page doesn't make sense if you are offline, right? If you type the user password and so on. Or fallback, like in the case of going offline, then please use this. So if you see this, you can realize that the green, the blue, and the red, they define these categories. And if it's difficult to understand this, then use this table. So when the user is offline, you can put resource that you think the user needs to access from in the cache, and if you want to be only online, you put it in the network, otherwise use fallback. So using this, a lot of apps can deliver really smooth experience and it goes online or offline. So if you use, if the device or the phone, smartphone, tablets, whatever you're using, goes offline, then automatically the browser will take from its cache. And it's because it's cache manifest, it's not something that is cached by the browser. It's a manifest that tells the browser to cache certain stuff. Then you're not worried that, oh, suddenly this resource are not there anymore. It works across multiple browser, multiple devices. I think only very old and very prehistoric mobile phones doesn't support these features. Another way is local storage. So this is pure time-based. So on the global object, we have an object called local storage, and you can store items, you can retrieve it, you can clear everything, and do crazy stuff. So on typical browsers limited to 5 megabytes, some device allows you to increase the capacity by prompting the user. So if you install, for example, the Financial Times apps, then the first time it prompts you hey, you want to increase the storage size. Because obviously when you fetch all the news and images and so on, at one point it will grow beyond 5 megabytes. So local storage, you need to handle everything manually, and there are a bunch of libraries out there that helps you managing the resource that you need to put the local storage or you want to remove it. You can build a pretty complicated and sophisticated cache system on top of this simple API, and that's really helpful to help your application works when it's offline. Questions?
Yeah. Please sum it up. I'm a little confused about the local cache in HTML5. Are you able to, I've heard like enterprise inside people say you can't use the local cache because there's no encryption. Yeah, so if you're going to put data on your phone and it's in a local cache, then it's unencrypted. Is there some way to engineer encryption? Is there some way to make?
So the question is about cache and encryption. So app cache is not encrypted, but you can build on top of local storage your own encryption system. We can talk about that later on. Css3 animation. So if someone says to you, I want to build fluid UI, but I don't want to write manual code that, hey, please fly this object to that position, then you can use Css3 because the new standard from Css3 allows you to define keyframes animations. How many of you have seen this demo? None? Yeah, this is it. Let's see if this works. So when you click on a planet and then say I click on this and everything starts to move to the left or to the right, this is all done using CSS. So there's no manual JavaScript code needed to explicitly say that, hey, planet move to that direction. And I think it has some animation as well. Like if you watch carefully all the moons of Jupiter, then you can see that it's rotating. That's also defined with certain keyframe animation. And things are pretty smooth. I'm going to show you a demo why this can be really fast, comparable to native apps. So if you think about CSS3, if you think about animation, take a look at CSS3 and what can it do for you. Canvas, how many of you here use Canvas? Yeah, right. So there's the Canvas book, I guess, in the HTML5 kit, so you have to learn that. That's like a very nice resource. So Canvas allows you to create something like in the Q, it's called Q Painter. It's basically some sort of imperative API. There's a lot of frameworks and libraries that, out there that's built on top of Canvas, and this allows you to, instead of writing your own visualization, you can just take it and then use it. For example, this is called JavaScript Interface Toolkit, part of our labs project at Center, and you can do file system visualization. A bunch of different charts. There are tons of charts that you can use that. For example, tree map. Tree map is a very nice way to visualize size. In this case, it's actually about music, I believe. So later on in the hybrid section, I'm going to show you how to take advantage of existing tree map components and build your apps. And if you want to create games that can be played inside the web browser and deploy as an app, and you put it on AppUp, any kind of app store, even Steam, then you can also use Canvas. This is a demo of Space Invader running on Canvas. Pixel manipulation is also possible, and you have access to the raw pixel, and you can do crazy things like blending, image filtering, do any kind of image processing. I'm going to put all these slides on Slideshare, so you don't need to try to catch up with my movement here and get the URL. Factor graphics. SVG is a prominent component of HTML5 family. Usually it's very difficult to use because you need to understand all this crazy syntax. And again, another way to use it is by leveraging existing apps. So if you go to Raphael, it's a framework that allows you to create animation and then visualization using vector graphics easily. This is an example of the color block. take a look at the code of the power clock and see if you can understand the logic behind it. It's way easier than writing a code to draw the arc with different colors depending on the time and such and such. How many of you have seen WebGL demo? That's good, but could be better. So WebGL is a binding to OpenGL. So basically, anything that you can do in OpenGL, you can do now inside the browser. And modern browsers support this, including Chrome and Firefox. If the internet connection permits it, and this is actually WebGL aquarium. So as you can see, this is an aquarium, and I can change the view. I can remove the tank. Can increase the fish. Oh, there's a shark there with the laser. As you can see, 60 frames per second. Granted, this is a very modern MacBook, but the point is that there's nothing CPU intensive in this example. So all the browser does is pack your 3D code, pack your shader, send it to the GPU, and then let the GPU do the rest. Maybe there's a WebGL watcher. Has anyone seen this? And this is the fun part. Okay. I have to stop the gravity. Spacebar? Oh, it's paused. Actually, G. I can make it float by stopping the gravity. You can change the light direction. So again, you can create scenes using OpenGL or OpenGL running on your apps, native apps. But hey, why bother? Just use WebGL and then deliver it right in the browser. There's tons of crazy WebGL demo out there. So let me show you one of the things that we're also doing at Labs at Senja. It's called PhiloGL. So this is the temperature visualization from the last 100 years. Data come from NASA. As you can see, I can zoom in, zoom out, and it's all useful. Rotate like crazy. Then if I move towards today, you can see the temperatures are increasing. Fast forward. Impressive, isn't it?
Yep.
What about combining video and WebGL? Let me pause first so you know what is. So on the right side is a cube, which represents this color, RGB, and it's basically the histogram. So if you see black blob there, it indicates that the black color in the videos are dominant. So watch the video and see when it suddenly turns green and different colors. It's all done in real time. So HTML video is playing, every frame is captured, histogram is created, and the RGB cube represents the color histogram. You can even play with different color space, like if you this chroma, lumen, hue, or this kind of color schemes. I think the easiest proof if I stop at this new section. Yeah, it's mostly real-time video analysis and projecting it into WebGL canvas. So we're not going to watch a movie, so I'll move on. If you're confused which one is to be used, CSS, Canvas, SVG, WebGL, you can use this table as a reference. Of course, this is just guidelines. You can totally use WebGL to create your user interface. Now let's go to a different mode, so hybrid. So you got all these crazy features of web technologies. Now you want to put it in normal apps, native apps. One of the reasons why you want to use hybrid is because you have existing huge code base in C++. How many of you here have that situation? Yes. So you don't want to suddenly like convert all the logics to JavaScript or use any automatic transcoding for that, but you want to build your new UI with web technologies, HTML5, CSS, and so on. So what's the trick? So that's one of the possibilities of using it. Or you want to use advanced technologies. With web browser, you have access to device capabilities like sensors and so on, but not necessarily everything, right? You might want to have access to the camera. That's why you need binding, and you want to bridge the native features with what the web browser can do. Or you want to integrate with the platform. Or you want to put it in an AppUp or marketplace. Or you want to be secure. You want somebody to look at your JavaScript code. So at Sencha, we deliver two real-world hybrid apps, Designer and Animator. The former is what you see is what you get drag-and-drop visual GUI Designer to create your web apps. And Animator is a Css3 animation tool. If you ever use Flash or similar Flash-based tools, it's very similar. And the way we do it is that we develop our apps in HTML, CSS, JavaScript, but we deliver it as a desktop apps to the users. And it has native file dialog, it has native menu, it integrates very well with the desktop. And the trick to use this is to just leverage WebKit. As you know, WebKit is everywhere. I don't need to explain this. Again, missing the Tizen logo, but I'm sure you can forgive me for that. WebKit is a crazy project if you look at the project timeline. Horizontal axis is years. We just passed the 1 decade of development, and vertical axis is the revision, the commits that goes into the repository. As you can see, the trajectory is going like almost vertical anytime soon. So it's really important to leverage this fast-moving, rich project because you don't want to get all this stuff from scratch. And you can see a lot of projects adopt that approach. There are important components of WebKit. And if you see DOM, CSS, SVG, HTML, this all maps into the web technologies that you use when you develop your apps. And JavaScript is, of course, responsible for the JavaScript interpretation. Everything in WebKit is platform abstracted. So if you can see this, then the network part of WebKit is actually using real network stack running on your platform. So if it's Mac, it's like real Mac network stack. If it's Migo, then it's Migo network stack. I want to highlight the graphics part because if you have WebKit running on different platforms, then on different operating system is actually use whatever graphics stack on that system. So WebKit code only speaks to an interface called graphics contacts, and this maps to core graphics on Mac and then QPainter on Qt. It means that if you use Qt WebKit, you actually use Qt, and you won't have differences in painting behavior. If you use Qt WebKit, there are 3 important classes. So Qt WebView is a widget. It's just like if you have a browser, anything that inside the Chrome is called WebView, and in Qt terminology is called Qt WebView. Qt Web Page is actually the object that represents your web page. You can use Qt Web Page if you need to process a web document without displaying anything to the users. And every web page has at least one frame, which is the main frame, and it can have multiple frames depending on whether you have iframes or not. So the easiest way to use web views like this is like 3 lines of code. Forgive me again for not using Tizen website there. And if you want to set the contents not from a URL, then you can say, hey, this is my content, and put it there. This is important for hybrid apps, right? Because if you want your hybrid apps to work without internet connection, then you cannot put your apps outside the questions.
Yeah, does the Qt WebKit solution take care of the same source problem?
The question is whether the Qt solution takes care of the same source problem. Yes, you can customize via some settings. So this is fine, but you don't want to type your entire HTML code in your C++ source file. That would be crazy. So you can use the Qt resource system. How many of you here are familiar with the Qt resource system? Right. So basically, you create the manifest file, and everything that is in the manifest is actually compacted and then stored within your executable. Everywhere you move the executable, it has everything it needs inside the resource. So you can use the same to load the URL. There's a magic URL called QRC that's internal to Qt. So every time you use that URL, actually it looks into the application resource and then fetches something from there. So if you have a big assets, the HTML5 is big, JavaScript is huge, then instead of typing it inside your code, you should put it. Again, as I mentioned before, you can just use web page if you want to deal with the web page without showing something to the users. So this is a way to capture web page. As you can see, it's really simple. This is a demo that I've done like more than 2 years ago. You can use it, for example, to rasterize an SVG or any kind of vector graphics that you want. Or you can build a Google thumbnail. Back in 2008, Google didn't support this, so this hybrid apps that I created was an example of using Google to search for terms and then actually fetch every URL that the hit shows and then create a thumbnail out of it. So this is doing thumbnail on the client side. Now, say you already have a huge code base in C++, classes, objects, and so on. You want to be able to access it from JavaScript because that's the way you want to bridge these two worlds, right? There's this native world and there's this web world. So one way to do it is to use the bridging features from Qt WebKit, and you can instantly add any objects to your JavaScript world. So using this JavaScript in the object. So the easiest demo is that if you have this QObject subclass called dialog, which has a slot called soMessage, you can make that instant of dialog available to your JavaScript world. Let me see. Yeah. So if you have this button and then the on-click handler of the button actually has this line dialog.soMessage, then what it does it's moving the control flow from the JavaScript world to the web world, call the soMessage, and then pass the string. So if you see it here, soMessage is exactly the slots there. So the bridging system understands that there's a slot called soMessage, and you can call it from the JavaScript world. This is usually easier demo than say, if that works. So what I do here is, if I click on this button, there's a JavaScript code that call dialog.soMessage with the string that I passed in. So if you see, this is a native Qt dialog, which is really native depending on the platform. And that shows exactly what happens here. So if you look at the code for this, so that's one. So the click handler on the button actually just fetches the text that I put in my text field and then call dialog.soMessage for that. Again, this seems very simple, but this shows that hey, you can trigger a native stuff from the web. So if you have tons of collection of objects inside your native apps, you can bridge this easily. What about signal and slots? Fortunately, the Qt and WebKit bridging handles this. So if you have an object called foobar here and it has a signal called modified, you can connect it to a certain function. An example, there's a stopwatch there, has the signals called tick, and then every second this tick will be emitted or invoked, and then we're going to catch it on the JavaScript side. Again, this is the reverse of the previous stuff. So it's something happening on the native. You want to be able to do something in the web world if that happens. This is a demo. So I have the stopwatch. Tick signal, I connect it to this function. So what it does is set the content of an element with whatever value I pass to that emitted. In this case, for simplicity, I'm just increasing the number every second. So if you run that, then all you're seeing right now is that this number. So these numbers, well, you don't need to do this through native because you can use JavaScript timer for that. But this is just to demonstrate that anything that you do on the native side, you can bring it to the JavaScript world. So what about if you want to execute something from the native side, execute something on the native side from your web world? you can use this evaluate JavaScript, which passes a function, which passes a string that's going to be executed as if you type it from your, say, console on the webhook. And the beauty of this is because it comes back with a Q-variant, and Q-variant essentially is as a mapping. How many of you are familiar with Q-variant? Think of it like a map or like a hash. Basically, there's a mapping between another Q-variant string, and that's exactly what JavaScript object is. So if you pass a very complicated object back to the native word, you can decode this easily. Based on these three features, passing information from the native word to the web word, coming back again, evolving something on the native word, you can do a lot of different stuff. Like you can create a menu using the Q menu and Q menu bar, and then have the handler on the JavaScript, or you can present a native dialog like what I've just shown. You can even integrate with notification if you want to have something showing up on the taskbar of the desktop. You can even have access to the system if you want to expose certain features, like you want to access file system. Then you can create a function in the native world that's going to be exposed, and then you show it in the web. So there are two. Hold on, let me step back. So debugging, because debugging in the native world is easy, especially if you use script writer. It has a beautiful GDP integration. But if you don't have that GDP integration in that web world, then you can use Web Inspector. Web Inspector is a standard debugging tool for WebKit. How many of you here have used Web Inspector? Let me show you. Yeah, I can just inspect element. This is actually Web Inspector. You can do cool stuff. Body. What is it? You can see that my DOM screen is roasting. Style. We get those. Anyway, you get those. Maybe I should just get the document title. Yeah, you can see this is exactly this one, and I can say this. Yes, you can see the tab change to reflect the new title. And you can inspect the DOM here, and then you can even see all the results that's loaded by the web page. You can access the network. If I reload this page, it shows the waterfall diagram of all the files fetched from the servers, and a lot of other crazy stuff. By embedding QWebView, you can also consume web servers easily. This is a Google Chat client that I've built in like 15 minutes because I cheated. So what I do is just create a web view and then embed the iPhone version of Google Chat. And you have that chat features in 15 minutes. So if you already develop an apps and then you want to integrate it with messaging service or any kind of service that already supports client and in the form of web apps, then you can just embed that. You don't need to learn the complicated protocol. Code editor. How many of you here use code tutor or any kind of IDE? All right, so IDE is very important. I use Vim, but really call it IDE. So you will be amazed to see what IDE can do. Not IDE, editor can do, and this editor is actually implemented in pure web technologies. So this is just DOM and CSS and HTML and JavaScript. And it supports syntax highlighting, different types of support for language, autocomplete, all those standard features that you expect from an editor. Now, if I'm thinking of having an editor in my apps, for example, for macro editing, whatever, I don't need to fetch a certain editing widgets anymore. I can just embed this. That's exactly what this application does. So this application is actually, let me load the file first. So this application is just embeds a QWebView that insert that code mirror components. And if you see that it feels like a normal editor, like if you have different themes, if you have dark color, As you can see, this menu are also including the WebKit bridge to the JavaScript port. I can even open a file, and this is a native Qt file dialog. But the editor component itself is a web-based component. So I was talking about tree map before. So tree map is nice for visualization. So I saw this nice tree map components on the website, and I want to build an app that shows the space taken by directories or folders in my file system. This is actually pretty easy because let me show you what the tree map is. So the web version looks like this. You can click it and it has a nice animation. You can also go back and break down there. So I take this and put it in my hybrid apps, and then instead of having a fixed set of data, I actually use it to crawl the directories. So if I run this, it's really fast because the directory is pretty small. Let me point it to different directory. So it's going to crawl all this directory, and this crawling process happens in the native side. So it's just normal Qt code. How many lines of code do you think it needs to crawl directories and collect all the data? 8? Slightly more than that. So this search function is all it takes to different certain directories, goes to every file, get the file size, goes through every subdirectories recursively and get all the files, and then present the data and then give it to the folder, the tree map components. And like the web-based version, this is actually interactive, so you can go in and do a deep down and then go back and so on. It shows all the size and so on. So instead of creating my own Qt components to visualize the size, I'll just take this and then put it in my hybrid apps. Again, a demonstration of doing something on the simple side, get the data, pass it to the web. And of course, all this app works offline because I pack all the HTML5 file and JavaScript inside the resource system. GPU acceleration, so I still have some minutes. So this is another myth, like, oh, I want to create web apps, but I don't want the apps to consume 90% of the CPU because it's doing crazy things. As you can see, either you use the WebGL way, which means that you actually write technically OpenGL code that passed to the GPU, or you use Css3 Animation. And the way Css3 Animation works is by leveraging certain features of the GPU. So the thing that differentiates a game and a web page is, you can see this, these games consist of objects flying around, and web page is mostly text with a bunch of images here and there. Unfortunately, hardware acceleration has been designed to optimize for games. So if you know, like, the graphic stuff, sometimes if you use OpenGL to draw something, drawing a textual triangle, like, it's really fast compared to draw a line, because hey, who draws lines? You want to draw some objects and then move it. Which means that the browser developers needs to employ certain tricks in order to take advantage of the GPU that was never designed to accelerate web page, and then use it to accelerate web page. So one of the ways to do it is to break down the objects or the shapes on the web page into something that the GPU can efficiently render. So if you see a letter A, that's actually consists of a bunch of curves there, and then you fill it. And anti-aliasing complicates the matter. If you zoom in, it's actually not just gray and white. There's certain pixels that are in between, so that when it zooms out, it gives the impression of really smooth letter A. So primitive drawing is one way to take advantage of GPU acceleration, and most WebKit implementations these days do that, including Qt WebKit. So if you use OpenGL graphic system in Qt WebKit, then you're going to take advantage of the GPU to a certain extent, of course. And another is backing store. How many of you here use a browser that when you zoom in, zoom out, you see the checkerboard pattern? Right. So that's actually a trick. So if I display this is very complicated and famous tiger head, not Tiger Woods, don't confuse this. So if I zoom in and then zoom out quickly, you're going to see that momentarily it displays a very blurry version of all this curve. And then there's a checkerboard pattern. So I'm going to switch to debug modes and then exaggerate slowness so that you can see what it is. So the trick is, instead of drawing to the screen, the browser actually renders to a buffer, and then as you zoom in, zoom out, it's just like scale the buffer up and down. And then once you stop, or when there's an idle moment, then it actually renders everything in the correct resolution. This is evident from this debug version. You can see all these rectangles represent the tiles. If I move around, the browser just moves the tiles. If I zoom in, it's actually just zooming in the tiles, and then when it has the time, pre-creates the entire viewport with the correct size of the tiles, and as you can see, everything's sharp again. Same if you zoom out, momentarily there's a checkerboard pattern because there's like a filler for something that's not ready yet. Same if I move left or if I move right, the browser tries to catch up and then creates all these tiles as needed. This seems to be simple, but this decouples the user interaction with the rendering because web apps can be very complicated, web apps can be very rich, and you don't want the user to wait because you render a very complicated UI. So even Fitweb it supports backing store. Another way to do efficient animation using GPU is something that's called layer compositing. So with normal frame-based animation, if you move a box from left to right, then what it does is for every keyframe, it draws the box in a new position. That's very inefficient and that doesn't map into what GPU can do. So in the compositing mode, what it does actually renders the box onto a certain buffer and then push it to the GPU as a texture. And then as you animate, actually just tells the GPU, hey, by the way, that texture moved the position. So it doesn't push anything to the GPU anymore. And matrix transformation is something that any GPU can do easily. Again, this is easier demonstrated using an application that I built. So this is a falling leaves demo from WebKit. So what it does is create like 300 leaves falling down to the ground, and as you can see, 17 frames per second. So it presents a really heavy pressure to the engine and the graphics stack in order to draw every single leaf in every single position for every single frame. So when you switch to the compositing mode, what it does actually captures the leaves and put it in texture and then move around the texture. So if I switch to this compositing mode, then suddenly there's no limit of the frame rate anymore because it depends on how much GPU can handle this, and for like a couple of hundred leaves, that's not a big deal. That's the debug mode here. You can see all this texture. So if all the yellow rectangles actually represent the texture. So as it falls down, we don't render the leaves anymore. We just tell the GPU, hey, the leaf position is in this place. It's rotated like this, and as you can see, when it almost hits the ground, it disappears. So just that the new opacity is this value. So all of the technologies exist and are being used in many WebKit implementation that allows you to create very fluid animation. And if you look at the GPU perspective, what it does actually layer one elements on top of each other. That's why it's called layer compositing. And as long as the content of the layer doesn't move or doesn't change, then you don't really need to deal with uploading something to the GPU. So hopefully I've shown you that you can use web technologies to build pure web apps running straight off the browser and to deliver or use web apps in your native apps and deliver something that's integrated nicely with the desktop or the platform. And if you have huge code base in C++, you can use this hybrid approach to sort of mitigate the problem of converting everything to web commerce. Thank you very much.